Hello, good morning, good afternoon, or good evening, wherever you are in the world, and welcome to SQL Professional to Cosmic Superstar in 75 minutes. So, we'll be spending that amount of time together, hopefully taking your SQL Server professional skills, whether you're a developer, a DBA, an architect, and comparing, contrasting them, and seeing how they compare to CosmosDB, and hopefully giving you some insight into the pros and cons, the differences and the between the two databases. I'm Martin, and I'll introduce myself a little more shortly, but before then, just a little bit of housekeeping. You've probably seen this slide a number of times already, but PAS is a global organisation powered by volunteers mainly, providing a lot of content which they give away for free, although they have introduced a paid tier which is very cost effective and extremely cheap. So I'd encourage you to have a look at that, and also explore the various user groups and SQL Saturdays, and basically just the content in general that PAS have out there. So if you could evaluate this session when it's complete, that would be absolutely great, and evaluate as many sessions as you've been to over the course of the week, or you'll go to over that time period. Evaluation helps people like myself, other speakers, get better, tweak what they're good at, and essentially makes the presentations and their performance better for you and everyone else. So that's me. I guess there is a difference between virtual and in-person demonstrations. We haven't seen that please silence your cell phone slide. So if you have got a cell phone, feel free to obviously keep it on. Folks, this is me, Martin Catherall. I'm a data platform consultant based in Brisbane, Australia, over on the east coast of Australia. Originally from the UK, I spent a lot of time in New Zealand, probably moved over there about 2000, and moved to Australia about 5 years ago. Ended up in Brisbane at the start of this year. So I'll just make myself a bit bigger for the minute while I say hi. So I'm a data platform MVP, lucky enough to have had that award for a number of years now. I volunteer as a PAS regional mentor in the APAC area, that's Australia and New Zealand, stuck down here at the bottom of the world, and hopefully next year we can all be back together again in the United States, Houston, Seattle, wherever it chooses to be, and we can be hanging out and not just doing virtual sessions, but going to various activities, doing various things together. But until then, for the rest of this session, SQL Server to Cosmic Superstar in 75 minutes, I shall put my glasses on. I'll make myself small again, or disappear for a while. If I need to pop on screen, I will. Not sure that's going to be necessary for the rest of the presentation. So enjoy, and let's get into it. So let's have a look at how we're going to spend the next hour or so together. And the crux of the session generally is, if you can do one thing really well, can you translate those skills to something else, something a little bit different but sharing a lot of similarity? I guess it's like, driving a car. If you can drive a car and you can ride a push bike, can you ride a motorbike well? Can you do that the other way around? If you can drive a car well, can you translate those things to navigating a boat? All things that share commonality but are ultimately quite a little bit different, and we need to tune our skills from one thing to do the other. And so I'm going to leverage what we know about SQL Server. So I guess one of the expectations of the session is that you know SQL Server reasonably well, and then we can touch on how you can translate them skills from one thing to another, evaluate the pros and cons, how things are different. It's very unlikely that in the CosmosDB stuff we're going to come across something that's exactly the same. They're going to share a lot of similarity. Obviously, we're dealing with data, we're querying, we're putting data in, we're drawing data out, and that's basically where the similarity stops. How we achieve those things are a little bit different in CosmosDB compared to SQL Server. And then I guess at the end of the session, you'll be able to answer the question, why would I use CosmosDB? What would it be a good use case for? And where would I not bother with CosmosDB? Where would I stay with SQL Server or some sort of other relational technology? So that's what we're going to do. And so I'm just going to list off a few things here that we're going to look at. It's not an exhaustive list or a list that we're going to work through sequentially, because lots of these things are going to merge into one, and when we talk about one thing we can also talk about the other. But we raised the question, where do we start? And we're going to start with setup in the Azure portal. We're going to set up a CosmosDB and look at some of the terms and things that are introduced there. We're going to interact with the Azure portal for literally everything we do in this session. Clearly there are other ways to interact with Azure resources in general and CosmosDB in particular. We can use PowerShell or various APIs, C#, that sort of thing. But for the purposes of this session, we're mainly going to be looking at concepts, and they're quite clearly stated in the Azure portal. So we'll stick to that. We look at storage, how some of our decisions about the data can affect the underlying storage and can help us or possibly give us problems. And we'll contrast the term partitioning in SQL Server and also CosmosDB. We'll look at the query language. Obviously we use T-SQL in SQL Server. Very SQL-like language in CosmosDB. If you know T-SQL and if you also know JavaScript, it's kind of a combination of the two things. And most SQL people should find this relatively straightforward, as a lot of the concepts are the same. Now, consistency is a big deal in the relational database world. Everything's transactionally consistent. That's not necessarily the case in the CosmosDB world, in the world of document databases. The global nature of CosmosDB can lead to maybe eventual consistency, which is a bit of an alien concept for the SQL Server professional, but we'll look at why eventual consistency might be advantageous in a multi-model scenario, and why it might be preferable over fully strong consistency, as it were. We'll also look at high availability and disaster recovery. In a CosmosDB scenario, we can have multiple write replicas all around the world. Clearly, to do that in a relational database, we'd have to jump through a few hoops. Now, we can set up things like always-on availability. We'll have like one write replica and the rest will be read replicas. We could do things like replication, merge replication. That'd probably give most DBAs and SQL Server people a bit of a headache and maybe make them run a mile or two. So we'll compare and contrast that. We'll have a brief look at billing. Now, we're not going to talk numbers or dollars or cents or whatever, but some of the things that could catch you out in a billing scenario. What are the units of billing? In a CosmosDB world, it's resource units. In Azure SQL, it's something else. In analysis services, it's termed something else. But in CosmosDB, it's termed resource units. And we'll also look at indexing, maybe as part of querying, and we'll visit a few other things on the way. Now, just generally speaking, CosmosDB is what's termed a document database. And looking at some of the websites that compare and contrast different data platforms, I see some of them term SQL Server as obviously a relational database, but they say it's a document database as well. So what do we mean by a document database?
So it's basically a database that stores easily queried documents. Things like XML documents, things like JSON documents. In fact, that's what CosmosDB will store, JSON documents. Now, clearly SQL Server stores those two things as well. It's got an XML data type. It hasn't got a JSON data type, but it's got lots and lots of functions that came along in 2016 to query JSON and help us out there. But there's no real way, I don't think, you'd use SQL Server for that type of thing. You might use it as part of your database or part of your application, but I don't think there's any real way you would exclusively use SQL Server as a document database. Whereas CosmosDB deals exclusively with JSON documents, and that gives us a lot of flexibility. We can do things like change schemas easily, which we can't really do in SQL Server, and that's one of the fundamental differences, and we'll dive in and have a look at that. Now, the terms that are used, you should pay particular attention to them because they might lead you to believe that they're the same. For example, we'll talk about the core SQL API. It doesn't use T-SQL, and it's similar but not the same. We'll talk about things like language, consistency, recovery that we've heard about. We'll talk about partitioning, and you might hear APIs and think of one thing whereas actually they're used meaning a complete different thing. But we'll look at all that in the setup.
So let's dive into setup and have a look at that. We see a screenshot of the portal. We won't look at that. We will actually dive straight into the portal. So over here on the left hand side we've got CosmosDB. We'll click add and we are met with this screen to create a CosmosDB account. Note the terminology account. It's not a server, it's not a database, it's an account. And we've got a few generic decisions to make. Our resource group, the name of our account, which has got to be all lowercase. And the first thing I really want to draw your attention to here is API. Now, CosmosDB is a multi-model database, globally redundant, planet-scale multi-model database service. Sounds a bit like introducing a heavyweight boxer. But effectively, we've got a number of different, what you might think of as database models. So I kind of think this API could have been termed model or database type or words to that effect. But in actual fact, it's a choice of the different database models that we have. Now we'll come back to the core SQL API very shortly, but let's talk about the Mongo and the Cassandra APIs here. Now clearly they're open source databases, and Microsoft has provided us with a pathway to migration here. So what you could actually do is take an existing MongoDB, for example, set that up in CosmosDB, migrate data and that to the MongoDB, change your connection string, and we'll have a look at connection string shortly, and that should be totally transparent to your users. So that's a strong pathway to migration for those types of database. We've got the table API, which is basically a key value pair, which probably most people here are familiar with. And we've also got the Gremlin API, which is a graph database API, similar to Neo4j and that sort of thing, Tinkerpop, that sort of thing. So that's the first decision we've got to make. We're going to choose the core SQL API, and in fact all of those APIs work off some sort of JSON document type feature. So before we push on, you'll notice that up the top we see a document DB, and CosmosDB was it's been around for about 10 years or so. It started life in Microsoft as like an internal project and was used to back a lot of internal services there, and even today it's still used to back things like Xbox and gaming and that sort of thing. And then it came into general preview, and there was only really one model in the database at that stage, and that was termed DocumentDB. And in fact, the entire product was not termed CosmosDB at this stage, it was termed DocumentDB. And so historically, when you go and look at things like different APIs or even documentation and that, you might see the term DocumentDB rather than CosmosDB, and that's just a historical hangover. But we'll choose the core SQL API here, and then we can choose how we want to, if we want to interact with that via notebooks. I could turn that on, and you'll notice that the location changed a bit there. Obviously, there's a preview feature and not available everywhere at the minute. Notebooks are obviously quite ubiquitous at the minute and in a lot of things, so we'll actually turn that off for the moment. And then we can choose our location. Now, one of the things that I want to point out here is if you look down towards the bottom of the screen to where it says multi-region rights, you'll notice that there's nothing underneath there. But if you watch when I change this to something a bit closer to me that I actually want to, I want to set it up, Australia East, that's real close to me. You'll notice that now we've got down here availability zones. And the Australia East data centre is obviously paired with another data centre in Australia, but in a different region. And so if I were to change this to somewhere where I know that the things are not paired, where can we look at? We can look at Germany, West Central. You'll notice that we can't have that redundancy there because the data centre isn't paired. But let's put that back on Australia East. And we get that choice back again. Now, second thing we got to make the decision about is how we're going to be billed, or basically capacity, or more commonly our throughput. Now, we can provision this in advance, or if we don't want to provision it, we can look at the new serverless offering. And that might, your database service might spike at different times, and so you want to pay for it in that manner rather than knowing up front that you're maybe going to use a certain amount of resources. And those resources in CosmosDB, no matter what API you're looking at, are termed resource units. And we'll get this all set up first, and then we'll have a bit more of a look at these things. Now, you get the option to set up a CosmosDB for free if you want to do that, and you can apply that here. I'm not actually going to do that, but obviously you can get free Azure accounts in there, and you're not limited to setting up CosmosDB or anything in there, but I'm just going to leave that for the minute and click apply. The account type for production, non-production, I think that's more of a safety net to stop you maybe picking production and enabling things like Geo Redundancy, getting up a higher bill when you don't effectively need to, because you'll notice if I change that now to production, you've got Geo Redundancy and multi-region rights enabled by default, whereas non-production you haven't got that enabled. Now, these can all be changed after the fact. Geo Redundancy is obviously what it says, it's geo redundant. Multi-region rights, now that's not something we're really used to in the SQL world, writing to multiple databases at the same time, and for most SQL professionals that's going to bring up a whole load of questions around conflicts and that sort of thing. But we can enable multi-region rights if we want, and I will enable them for the moment. And obviously we can pick our redundancy in availability zones. Actually, I won't pick multi-region rights. We will change that at a later date and have a look at that. Now, then we can flick over to networking. And by default, all networks are on Azure. I've got access to this. I would advise to maybe set up your own networks and lock things down a little more. And I've just got a slide after this just to talk about security ever so briefly. But the setting up networking obviously in Azure is not as hard as maybe you think it is. I'm not a networking person, and it's not that intuitive to me, but yeah, I found a pathway and not so hard. But this session isn't about networking, so we'll ignore that for the moment. You can set up a different backup policy. By default, your database will be backed up periodically. You can see the backup settings here, the intervals in minutes or the backup retention. And notice that as you change these numbers, we can obviously have something between 8 and 720. Let's change it to 100 and change that from. You'll notice that the copies of the data retained down here changes. Obviously, when you change the days, you can only pick between 1 and 30. Let's pick 20. And that's basically the amount of backups you're going to have available to you at any one time. And obviously, with that rolling window, that will kind of change. So we'll talk a bit more about restoring in particular very shortly. But you can have encryption, which is similar to what we know as a transparent data encryption in SQL Server. You can let Azure basically manage your key, or if your processes dictate, you can have a customer managed key. Obviously, we can tag things as we can with any Azure resource. Tagging is a great way to identify resources, and I think we're probably going to be able to start to do other things with tagging as we progress down the cloud path. And then we just basically review and create. So I'm going to create. That's going to take a little time to create, but we're not going to sit here waiting for it. We're going to briefly mention the networking options that we've got there. And I think we should lock down things as much as possible. And it's amazing the amount of layers the Azure services have got around helping us protect things. And we'll just have a look at them. So we've got data in the middle and around, obviously, our application. But we've also got the option to kind of limit the compute and the networks that interact with our data. And that's probably a good thing to do. So maybe put your production data in a different network than your test data and your test CosmosDB or your test Azure application, whatever the case may be. Occasionally, we've seen people set things up and just, everything in Azure can access everything in Azure. It's all on the same network. And then they end up giving the same level of access to the production as they do to the test. People make mistakes, and what should have gone to test goes to production, and so forth. So if you can limit those things, it's probably a good idea to do so, and to have some kind of really defined processes around that. Microsoft have got a lot of smarts themselves around the perimeter, things like preventing DDoS attacks and things like that. And then limiting our identity and who can access all these things is a good thing. And finally, obviously, we don't have to worry about the physical security, but that's all taken care of. So let's have a look at storage. Now, I've grouped together storage, partitions and documents because they're all kind of connected. Now, we don't define the location of our storage at all in CosmosDB. In fact, for the most part, that's totally transparent to us. However, the choice of partitions and partition keys can have a big effect on the storage. They can only be a certain size. It is a big size, but if you start approaching that or get near it, it can be a little tricky. And before we start looking at that, we need to look at documents, at Json documents in general. So I've grouped them all together. I think they're all kind of connected. So let's have a look at a document. And we put in 4 very similar, very simple Json documents here. And as you can see in the first one up here, all we've got an ID, a first name and a last name. And if you kind of look at these 4, you can pretty much see what they're about. They're similar, or some people might say totally different. But the point is, they all share one characteristic, and that is the ID. So they've all got one thing in common. Now, if we were looking at this from the perspective of SQL Server, from a table perspective, we might look at this and go, oh, we've got 4 totally different things there. This one talks about names. This one talks about something called objects, whereas this talks about items. And this appears to talk about some sort of sporting fixtures, home and away teams. So these are all clearly different. We would not think or even go near putting them in the same table. However, it is possible, if unlikely, that you could actually put them in the same container in CosmosDB. All documents need to have is really 2 things in common. First thing, they need to be JSON documents. In fact, they're not going to go in a container if they're not a JSON document. And they all have to have an ID in common, whether that's a system generated ID, which the ID would be here, or what we call a partition key, which can be a separate key. Now you'll notice here that the ID is actually, even though it's a number, it's actually a string. And if we don't put the ID in, CosmosDB will generate that for us automatically. But we can also have a partition key, which basically splits the data up into logical partitions. So if we kind of think of something we might be more familiar with, maybe states of the US, so there's 50 states, and we might have the partition key might be state ID. So every time we enter a state, Washington might be 1, New York might be 4, whatever, we enter states and they get allocated to different partitions. And you can kind of probably see as DBAs that we got 50 separate partitions there, and we can think of those as logical partitions. And behind the scenes, something that we we can't see whatsoever and we have no control over, those are placed onto storage and allocated into that position. And the partition key helps in actually searching later, but the partition key can't be greater than, I think at the moment it's at 10 gigabytes, and that's obviously extremely large because these documents in general are maybe a kilobyte, maybe less. Certainly they're not big documents, but we don't want to get anywhere near that limit, and that limit could change all the time. I use the number 10 gigabytes at the moment. If people watch this later on, it might be completely different. But we want to choose something for our partition key that is not going to create a hot partition. For example, if we had a lot of activity on, say, one particular state, let's say California, we wouldn't want a whole heap of documents going in with California. What might be good in that case to do was to pick a slightly more selective key, which might be district or something like that, where we're not really going to get near that upper limit, and we're not going to create a hot partition where we're always looking for California and dragging things back, updating things, deleting things from that particular partition. So kind of a little bit different to what we do in SQL Server. So I thought I'd just introduce that concept before we went over to the portal and we created our containers and we created our documents. But you'll kind of see probably the flow of things once we get in there and look at that. And I've included a link on this slide specifically that talks about partition keys, because the partition key is pretty much one of the key concepts to CosmosDB, getting this right is so fundamental. It can affect a lot of things. So we'll flick over to that link, and we'll see that it is talking about partitioning and horizontal scaling in CosmosDB. And not only does it apply to the SQL API, but it applies to every single API that we've got in CosmosDB itself. So as you can see, it is crucial to everything. It goes through and talks about logical partitioning, and then it talks about obviously physical partitioning, what we see behind the scenes. And it says that the number of throughput provisioned, each individual physical partition can provide a throughput of up to 10,000 request units per second. So as you scale, you'll want to check out the request units. I'm aware we've not really talked too much about those yet, but all of these things in CosmosDB sort of relate to each other, and a lot of this is chicken and egg sort of stuff. So introducing one thing before another can be kind of a little bit tricky. It talks about managing the logical partitions and choosing a good partition key. And this is like quite crucial to your design. Obviously talked about hot partitions, getting the partition too big, being selective, and so forth. And that is a key design concept that you need to get right. So partitions for heavy read containers, special consideration if your partition container is actually going to get pretty big and have so many RUs going to it. But that is a key thing you should keep by you. Read, reread, and read again, because getting this partition key wrong can lead you into all sorts of difficulties, and has led people into difficulties a lot in the past. And just while we're on the docs page, as we can see with most Microsoft docs, there's a link down here, right down the bottom, download PDF, and obviously clicking on it, it'll take a bit of a time to download, but it'll essentially download this whole set, which is the Azure Cosmos DB documentation set, as a PDF, and then it'll be kind of searchable by you. You'll have a local copy, fully searchable, really, I don't know, good way to learn and have handy when you're designing, troubleshooting, whatever. So I just thought I'd dive into that and point that out. The documentation is really quite good. Lots of quick starts in there. We'll see some quick starts actually in the portal very shortly. Lots of tutorials, samples, and resources on every one of the APIs. So that is that's basically the documentation around partitioning and other things for you. So hopefully one of the things you've got from that is that the partition key is absolutely quite crucial. So now let's dive back into the portal and look at a few other key things. So we flick back over to the Azure portal, gone into our CosmosDB account, and at the moment, well, imagine we have no databases. I have actually played in here previously, and I've created a few databases, and we'll have a look at them. But if we've got no databases, that's essentially what we need to do. We need to create a database, and underneath the database, we create a container. So in order to do that, we actually hit the add container link. And if we've got no database there, we get the chance to create a database if we need to. Or we can use one of the existing databases that I've set up prior to this. So let's go and set up a brand new database. Let's call it Cosmos Test 01. And the first decision we've really got to make here is how much throughput do we want attached to our database. Now we can either attach throughput to the database as a whole, or to the container that we are about to set up. Here we're attaching it to the database, and we're saying we can expect our users combined to be sending queries to our database, and we can answer up to 400 RUs of query in any 1 second. And if more queries come in than that we need additional throughput units, we can spike if we need to, or if we've chosen not to do that, we'll get back an error code, and we need to handle that in our application and maybe wait till the end of that second, and then we can service the request again. But we can up that. Obviously we can go from 400, which is the minimum, up to 100,000, and you'll see that the calculator below will change as I change the units in there, and watch I don't go above the 100,000 limit. If you do need greater than 100,000 RUs, then all you really need to do is contact Microsoft, and obviously they'll say, yep, you want to spend a large amount of money with us. That's absolutely fine. We'll make sure we have the capacity in our data centers, and willingly take your money. But good design can minimize this and really effectively make good use of your money. So that's the RUs, and now we need an ID for the container. So let's call this container first, well, we call it SQL pass container, what I can spell. And we can say on our container, do we want automatic indexing or do we not want automatic indexing? And this is something we don't have in SQL Server. Basically, when we create tables and put data in and add columns, there's no indexing done in the background. And a lot of DBAs and developers say, like, wouldn't it be great if it could automatically index our foreign keys and things like that? That's a bit of an ask for some people, but obviously SQL Server does not do that. But we can leave this on in CosmosDB and have Cosmos index every single attribute in our JSON document. Now that's probably going to add to the size in the background, and when we query, that will obviously have an effect on the performance of the query. Obviously it'll be quicker to return data, but it might be more expensive in terms of RU count. So that's something we need to consider carefully. Now we get to choose a partition key, and I'm going to make a key up. I'm going to say item ID. So all of the documents that we're going to add to this container, which is called SQL Pass Container and is in the database Cosmos Test 01. Every document that we add to this container is going to have the partition key of item ID. We got to choose if it's going to be bigger than 100 kilobytes, which it isn't, and we can link this to an analytical store. And this is it's not a new feature now, but it's came in within the last year, and it lets us do analytical processing within the Cosmos DB. So we can enable that should we choose to do so. I'm not going to enable it now because obviously I haven't been through and set up Synapse Analytics and linked it to it here. And then we can choose any unique keys that are going to appear in the documents if we want to. So I'm going to press OK, and that's going to go away and create our database, our container, and link our partition key. So let's wait for that to complete, and then we will jump over and add some documents. So with the account and database now created, let's head back in and see what we can do. So obviously go back into our account, and if we want to get back to the place where our database was, where we can see our database and containers, this is Data Explorer. Now it'd be great if there was like a Management Studio type or Azure Data Studio type tool. Still waiting for one of those. You can write your own using many of the APIs that are out there, but if you just want to interact briefly like we do, the Data Explorer in the portal is probably the place to do it, certainly for a demo. So we created our Cosmos Test 01 database and our SQL Pass container. So let's drop that down, and we'll obviously see familiar things. We can create stored procedures, user-defined functions, or triggers. But the one thing that we want to look at here is the items. So we can start adding JSON documents to our container, should we wish to. So we can upload them if we've got them handy, but we'll just basically go and create them. So when you create a document or add it, if it doesn't have an ID in there, Cosmos will give it an ID. We're going to leave that for a minute. What we will do, we said, and the ID here that's different. It can be the same as your partition key, but for the purposes here, it is different. So we said our partition key would be item ID. And let's call that item ID 3. And notice the save button up there. At the moment, this JSON document is totally valid. If I put a comma on the end of there, you notice the save button grays out because now it's no longer a valid JSON document. So all I'm going to go in and say item name, and I'm going to call it a bat for want of a better word. So that's a valid document. It's got our partition key in there, and it's got an ID in there that Cosmos is wanting us to replace with something familiar, so we'll call it 1000 for want of argument's sake. Very simple JSON documents, and all we're going to do is click save. And as soon as we click save, we get a whole heap of additional attributes made up from CosmosDB. And they all help behind the scenes doing various bits and pieces of internal processing. The one that's going to really interest us mainly is the timestamp. And so we haven't actually talked about the global distribution of Cosmos yet, but this is probably as good a time as any to bring the subject up. So for example, if we've got a database in Australia, and another one in America, and we're both writing to them continually, and they will both be replicating constantly. Now, if we've got, for instance, customers in Australia who only ever write to the Australian database, and we've got customers in America who only ever write to the American database, and the two things are syncing, then clearly if things carry on like that, then there'll never ever be a conflict. However, what happens if there is a conflict and the two records go to merge and they can't merge? Well, Cosmos has got a concept of last writer wins. So the change will be detected, and we have the choice of doing something about it. But by default, last writer always wins. And so if like the Australian one was put in more recently, that will be the one that takes precedence. And there's various things in the background we can do. We've got something called a change feed, or we can obviously use triggers. We can obviously archive that stuff off if we want to, similar to what we do in a relational database. Obviously this scenario is not that likely in the vast majority of situations, but we have the choice of dealing with those conflicts in a number of different ways. So we'll talk a bit more about these e-tags and selfs and rids later. But for now, the timestamp is probably the most important thing that we are interested in. So we've saved that. We can create a new item. We can obviously upload one. And that's basically what we can do here. And so let's have a look at some of the additional features that are within Cosmos. So we can actually link to Synapse Analytics and have data almost archived off, and we can do queries on there. We have to enable that, and obviously there's a cost involved. But let's have a look at something that might interest us more: replicating globally. Now we mentioned briefly how we deal with conflicts, but this map here sort of represents what Microsoft talk about the turnkey ability of CosmosDB, and essentially that means that we can add regions to where we are. So we see we've got our one right region there, and that's in Sydney. So let's add another to it, the data center over in Melbourne. When we set this up, we actually said we didn't want any availability zones, but now we've actually added one availability zone now. Note that these aren't actually added, they're not actually actioned until we press the save button up here. And it might take a little while to do. It may be reasonably instant. I guess it depends on what data you've got in your region or regions and how many regions you are adding or deleting or whatever. So we've added one there. Let's enable multi-region rights, and we can see there's obviously a cost involved in this, and Microsoft are going to tell us that there is a cost involved in it there to make sure we don't do anything that we don't want to there. And we can see there we've got rights enabled, reads enabled, and we can obviously get rid of those if we want to. And we could add different regions around the world. For example, say we were rolling out a new company. We wanted to go global at one point, but just to begin with, we wanted to base ourselves, say, in Japan. So we open our Japanese site up, start selling products, then we expand. We want to open one up in America, but we don't want we obviously don't want the American customers using the site in Japan. So we can easily replicate our database over to America, make it quicker for the American customers, and the ability to almost merge those two sets of data gives us additional high availability. We probably set up so the Americans ones are writing to America and the Japanese ones are writing to Japan. But obviously, if one of those did go offline in a very, very unfortunate situation, we could change things around. So maybe they were both writing to Japan or both writing to America. But it's very easy to add or subtract these data centers around the world. Obviously, they're all in pairs, or most of them are in pairs. I'm not going to actually action this because this might take a little while to do. But that's what you can do there. So now we can have a look at our default consistency, which is a little bit different than SQL Server, and most DBAs or SQL Server people might find the concept of the consistency here a little bit odd. You can see at the top we've got 5 consistency levels, and the default is right in the middle on session consistency. So over on the very left hand side of the screen we've got strong consistency, and that's basically saying if you write to one region, then don't let anyone else read it. That data must be committed in all regions before people read it. So if people if people enter something in America, it must be committed in Australia before people can read it. And that's people even in the American data center where it's coming from. Now we can contrast that with eventual. And eventual is something that we're probably all familiar with, even if we don't really deal with it every day. I mean, if you think of your social media, if you enter something on your I don't know, your Facebook or your Instagram or that sort of page in America, and you got a friend over in Europe, well, who cares if your friend over in Europe sees it 10 minutes, half an hour, a day later? It's no big deal. No one's going to lose any sleep either way, but eventually at some point everyone will see it. And if you do have lots and lots and lots of processing going on around the world, I guess things are, not going to be eventually consistent all the time. They're going to be constantly changing around. If you imagine people using social media all over the world, all them things are probably never really ever synchronized. They're all a little bit out of time elsewhere. And session consistency is basically a halfway house between the two, with bounded staleness being obviously a halfway house between a session and a strong consistency, and the consistent prefix being exactly the other way between session and eventual. And they basically balance all of these things up between strong and eventual. And you can see the little musical notes there to indicate what is happening in the various regions where I am doing this, like in Southeast Australia, Australia Central and Australia East. So that's the consistency. I'm going to discard my changes there because I don't want to. Now, backup and restore is something that's probably really going to surprise a lot of SQL Server people. And we kind of seen this a little bit when we set it up. We can have multiple backups going on. The big thing people have got to realise here is you don't have that much control over your restores. In the SQL Server world, it's pretty much something that DBAs practice all the time, but that's their bread and butter. If things go wrong, they need to restore the database, to change whatever settings they need to change, bring the database back up in a timely and good manner so that it ends up consistent, not lose any data, or certainly not lose any more data than our SLAs permit. And all the things we're going to want to do with Cosmos. However, if you do need to restore in Cosmos, you need to ring someone up. And if you think, well, when you plan, you hope that doesn't eventuate, but it may well eventuate, and we'll talk about why it might not in a minute. But if it does eventuate and you've got to talk to someone on the phone, you're going to have to supply a certain amount of information, and you want to make sure that you've got that information to hand to give it to the person on the other end of the phone so that they can do the restore for you straight away or within a couple of hours at least. And so, I mean, a restore generally is probably a lot less common than it is with a SQL Server database. For example, you've got lots of global distributed databases with Cosmos around the world, and they are replicating to each other continually. And so if you lose one, you may have some data that's not gone across, you may not. You may be able to salvage something from the other replicas around the place. And I guess so long as that's within your SLAs, you may not need to restore. But it's always best to know what's going to be needed if you do have to restore. So obviously you can speak to Microsoft and get them to do it properly. So firewalls and virtual networks, probably something that we're familiar with. We had a look at the security stuff previously. Endpoints and connections. Cross-origin resource scripting, not something we're going to delve into a lot here, but something we will be interested in is the keys. So in order to access Cosmos through our APIs and things like that, we're obviously going to need the URI, which has the name of the account we set up in the first place. But something that is totally kind of ambiguous to what we do in the database world is a primary key. So if you hear people in the Cosmos world talk about primary key, they do not in any way, shape or form mean the same thing as it does in the relational world. This is basically a key to be used to connect to the database. So basically a key to be used in the connection string that takes care or enables a bit of security. And we can see the key is there, and in the primary connection string there we can obviously see the key there. And you've got two of these just in case one becomes compromised and you need to switch around to the secondary key. And if you think you're going to have to do that, you should have a process in place in which to do it, so it's seamless and doesn't impact your customers very well in any way. But basically a primary key in the Cosmos sense is not attached to a table. It doesn't define uniqueness in any way. In fact, it's absolutely nothing to do with data at all. So that's the key. And obviously we've got our read-write keys that we can use for read-write connection, and we've got read-only keys there. Now we can add things like continuous search, Azure functions, and there's an advanced security preview in there to help protect our data. And as with any other Azure resource, we can create locks. I think we can create delete locks and read-only locks on our database there. Obviously there's probably reasons you can think of why you might not want a read-only lock, but you might want to stop someone from deleting your database unnecessarily. So let's now talk about containers again, and we'll go into the scale section. Now we've got something here called time to live, which is actually a tremendous useful feature, and one that I think a lot of SQL people might like to see in SQL Server. Basically, time to live is a setting that we can put on our containers, or we can even put it on documents, but essentially on our containers. It's turned off by default, but we can turn it on, and we can set a period of time before our item is deleted or removed. And that can be really helpful, not just getting rid of the data. I mean, there may be times where we're collecting, I don't know, monitoring data or some sort of data that we just want to hold for a brief time, and then we get rid of it. So we might set our time to live, for example, to a day, and if we don't need to explore it after a day, that's it, it just gets deleted. But what we can do in addition to that is we can put a time to live on there of maybe a few years or something. And when it comes to time to get rid of that document, we can actually have another process grab that document and archive it somewhere else. And that's like a really big thing for archiving. I'm sure lots of you have come across databases where, you know, they could do with archiving data off after a period of time, maybe a year, but it's got like years and years of data in there, and that's having a detrimental effect on the database. So having some sort of functionality that lets a record or an item in a container live for a specific period of time, and then have the ability to actually do something with that data is quite phenomenal and pretty innovative. So as well as that, we've got the scale. Now we looked at database units before, should I say resource units previously. We attached them to our database, And here we're going to say we're actually manually scaling. So obviously we can come in here and change that. We can go up, and again the calculator will tell us what we're going to spend. However, we can also auto scale that. Now this can be a very dangerous feature. It can be a very helpful feature on the one hand and a very dangerous feature on the other hand. Helpful because there may be times where we actually know we're going to scale outside that limit and we're kind of fine with that, but we actually know that it's only going to happen for maybe specific periods of the day. So we could actually change that that scale manually or by using an Azure function, so it's kind of not really manual, it's happening automatically, but we've implemented something to do it for us. Or we could actually auto scale, and the auto scale might handle that properly. I guess that the nightmare scenario becomes where we say, this is going to auto scale, and then we're continually scaling above the limits that we've defined, and that's when it's going to start costing us a lot of money. And I've unfortunately seen a few cases where this has happened. People have got queries coming in initially that have gone over their limits. They've set auto scale, left it, and then it's started scaling continually over what they set, and at the end of the month they've ended up with a massive big bill. And obviously if you're a small organization, that can have severe impact on your finances. Well, even if you're a big organization, it can. But if you're a small organisation, maybe the consequences are going to be a lot more severe. And we can obviously link that to Synapse Analytics. Preview notebooks. We've not really looked at notebooks, but they're so ubiquitous at the minute, notebooks, that I'm sure you've probably seen them in a lot of places. Obviously, we can do visualizations and queries in different languages and that, and you can do the same thing here. So that is the scale option. So one of the things that CosmosDB and Azure in general gives us is great metrics, and obviously CosmosDB is no exception to that. We can set up log analytics and have metrics go to that workspace. We can look at them with Power BI and all sorts of things. But one of the things I did want to specifically mention was the metrics tab in here, and specifically this graph over here. So we see some codes that have been returned off calls to the database, and the 400s, we'll look at them. If we take them away, we can see we've had no 400s, but we added a lot of 200s. I can take them away and the 200s are basically saying everything's alright, codes that have been absolutely fine. But one of the things you probably do want to check for if you're writing an application through the API is 429 errors. And when you get a 429 error, it's basically saying you've run out of resources. So you've said you wanted 400 RUs, and in this particular time interval, you've had requests greater than 400. So anything above 400, we're not going to service. And that'll probably just wait till the next second, but you will get an error code back, that 429, so you will know that has actually happened. And that is a great indicator that your Cosmos is getting a bit busier, and you might want to do something like adjusting your scale units. So do keep your eye on that. So a pretty fundamental thing for SQL Server DBAs or developers to do is to join tables. And I previously said that probably shouldn't pay too much attention to the analogy between tables and containers. And one of the big differences I see here is obviously we can join between containers. We can join container A to container B, and in a similar way to what we do in SQL. But that's going to be a very expensive operation generally. And also, if we're not using the partition key as part of the where clause, that can also be really expensive because the query has to do something called fan out, and that means it fans out across the entire partitions, and the more partitions you've got, the wider it's got to spread its wings to try and retrieve your data. So not putting the partition key in the where clause can lead to some problems, both performance-wise and cost-wise. In a similar way, joining between two containers can be problematic in the fact that it can be very expensive. So how do people generally get around that in the world of NoSQL? Well, two real ways, embedding or referencing. And referencing is kind of similar to joining, exactly what we just talked about. And even though it's expensive, some of the times there's just like no getting away from it. It's something we've got to do. So what exactly is embedding? Basically, the nature of a JSON document means that it's hierarchical, and we can basically embed one document inside another. So maybe instead of looking up document B from document A, we can embed a copy of document B inside document A. Now, obviously that brings with it some severe trade-offs. For example, we've now got data probably denormalized and in two places, and we're going to have to look after that as developers. But it's going to make our queries cheaper. Or potentially we've got to look at a different way of querying to query container A, get the data back that we want, and then go and query container B using the partition clause that's relevant for partition B. So it's all kind of a bit different, and it probably take a bit of a different mindset and a little bit of thought, and it's not exactly the same thing as SQL Server. It's a different way of thinking. JSON has a way of being more flexible. It's not as kind of structured as transactional tables and so forth. But yeah, it's definitely a different way of thinking. So one of the unique things about Cosmos compared to SQL Server is it is a cloud-first, cloud-only application, cloud-only database. However, there is an emulator that you can download and install, and it mimics the functionality of the Azure CosmosDB database in the cloud very, very well indeed. One thing it doesn't do though is it doesn't replicate that scale and that global nature. However, you can obviously write your stored procedures, write your user-defined functions, your triggers, and query inside the emulator. You can create containers, and it looks very, very much like the Data Explorer that is in the Azure portal. So definitely advise you to download that and have a play. Obviously test your applications in here, but have in mind that this isn't a place where you should exclusively do your testing. You need to move things into the cloud and maybe test in a non-production environment, and then test in environments that maybe mimic production a bit more. In both the emulator and the Azure portal, we can actually download quick starts. If we go to the quick start tab there, we can download applications and download an application inside the emulator to connect to our applications. And the emulator runs as a website. It's a service that runs on your local machine and exposes basically a website. And there's keys in there where you can link to the database created through the emulator. So it does a reasonable job of emulating the Azure portal, but not 100% compatibility by any stretch of the imagination. But definitely a useful tool to play with and have a look at. So we're drawing to a close. So just to recap, we've seen that CosmosDB is a cloud first and cloud only database. It's not a relational database, and unlike SQL Server, it has multiple models. So there's 5 models in there, or APIs as they're called. We only really looked at one, which is the the core SQL API, although it shares a lot of similarities with a lot of the other APIs in there. We had a look at Json Documents, and we found out that Json Documents are not tables. They are very flexible though, and joining between containers is possibly something we want to avoid. It's not avoidable all the time, but if we can minimize it, we can potentially cut down on the costs of CosmosDB. So we can reference or we can embed. And the flexibility of Json Documents let us embed one document into another. And obviously that brings some challenges with it. We've now got data in 2 places, and we need to keep that in sync. Now, if you've ever seen a SQL Server with, and some of you may have seen this if you're consultants, you open it up and you see lots and lots of tables in there with no keys whatsoever. And when you ask the developers or the architects or whatever how they manage transactional consistency, they generally tell you that their app handles it. And most of the time it does, but some of the times it doesn't. And if there's ever something like a data fix, there's no transactional consistency in the database to keep that there. And you could potentially run into the same sort of conflicts in CosmosDB. So definitely watch out for that. And they do offer a lot of flexibility, as we said, and it does require somewhat of a different mindset and the ability to, change mindset, think about things in a different way. And it offers different things. We've seen the time to live feature. Now, wouldn't that be a great feature in SQL Server, where if a table had data in there that was over a certain time, it would automatically get deleted or archived off or something like that done with it. So there's definitely things in CosmosDB that are a little bit different and could be really beneficial in the SQL world, but would likely not come there, or maybe they will at some stage. So dive in and experiment. Over the course of the last hour, we talked about setting up, we talked about documents and the keys that are in there. We've talked about creating the databases, the containers. We talked about adding data and explored the various functionality that's within the Azure portal. We've seen how to scale. You can provision or use up front, or you can experiment with the new serverless option, which is in preview at the minute. We had a brief look at the error codes, and at the very end we took a look at the emulator. So thanks you very much for listening to me for the last hour. It's been fabulous doing this. I hope to see you in Seattle or Houston or wherever we are next year. Definitely looking forward to traveling, even if it's somewhere remote. I've been sitting in Australia, not able to go anywhere for the last, it seems like it's more than a year now, but I think it's only since February or March. So I'd like to say enjoy the rest of the conference, but I guess you're sitting in front of your laptops like me, having fun. So thanks for listening. Have a great time. And fill in them avals. Thank you very much.